All right, question number 4 is from thermodynamics, and the question says something like this. For an ideal gas, initial pressure and volume is given. The final pressure and the final volume is given. That means from this state, it has been taken to this through an adiabatic quasi-static process, and the equation for that adiabatic is this. Now, since the adiabatic equation is given that it can be reduced into this, that means this will be the value of gamma. Now it says if the same gas is taken from initial to final, but now in 2 steps. So it's something like this. Originally it was taken through an adiabatic curve from here to here. And of course, look, the initial pressure is this, final pressure is 32 times reduced, the volume is increased 8 times. Now, we got to see this time at the second case, instead of taking through the adiabatic one, it's first expanded in this way isobarically and then brought back to the initial state through this. And in this, we need to calculate the heat supplied. Well, this is Pi Vi and this is Pf Vf. Let me first calculate the change in internal energy of this process. And after all, you know, change in internal energy either through this process or through this process is going to be same. So, change in internal energy would be Pf Vf minus Pi Vi by gamma minus 1. And let me calculate the work done in the second. Now, work done is path dependent. So, I need to stick through this path. For this, the work done is 0. For this, that would be Pi Vf minus of Vi. So, only the work is done in this isobaric expansion. So, now for this step, I have the change in internal energy. I have the work done. So, the total heat would be delta U plus W. Again, the question demands some arithmetic to a higher level, but finally, you would be landing to this option, option number C. Question number 5 is very beautifully framed from the experimental physics vernier caliper. It's a regular topic, but there is a very wonderful twist what has been made. So this is the first caliper C1, this is the second caliper C2, and I've made dot here just to show that these are the readings where the values or the scales are coinciding, because what happens is that when you make freehand, sometimes the figure may not be scaled. Now the first caliper C1, C2, main scale of both have 1 centimeter divided into 10 divisions. That's regular. For C1, 10 vernier scale coincides with 9 main. But C2, wonderfully you see some difference, that 10 vernier scale coincides with 11 main. So this is the one where the least count of vernier scale is greater than that of main scale. Now we need to find the readings in centimeters for C1 and C2. Let's go for the first case because that's a regular. You see, 1 Vs is 9 by 10 ms, and that of course you could see least count is 1 ms minus 1 Vs, and that's 1 by 10 ms. And you could see that the one main scale division is of course 1 millimeter, because it's been straightway said 1 centimeter divided into 10. So this is 0.1 millimeter or 0.01 centimeter. Now let's try to see the reading. For the reading, this one is the regular because that's 6, 7, 8. So for the reading would be 2.8 centimeter. That's for the main scale. And 7th vernier scale is coinciding. So 7th into least count 0.01 centimeter. So that comes 2.87 centimeter. So C1 is fair enough. 2.87 is in A, C and D. Of course, this is eliminated. Now let's try to go with the reading of C2. For the reading of C2, we need to be a bit careful. The normal formula will not be working here. So it's something like this, say. This is 6, 7, 8. Till this, it's 2.8 centimeter plus. This is the extra reading that we have to see. And how much is it? Let's see. 1, 2, 3, 4, 5, 6, 7, 8. 8 main scale minus 7th vernier scale would be this particular thing. All I did is say till this, because that much is the length what I have to find. So it's already 2.8 of main scale plus this additional. And this additional would be, because here is the coincide, this length minus of this length, and that's clearly written here. So when you put this value, say 2.8 centimeter plus 8 main scale, you could see the main scale division quite obviously is 8 into 1 main scale division. If you see, it's 1 millimeter, so that would be 0.1 centimeter, and minus of 7 times vernier scale. Now that's what you have to see. 10 vernier scale coincides with 11 main. So you could see 10 vernier scale is 11 millimeter. So in that way, you just put it here, that's 11 by 10 millimeter. And when you calculate all these things, the final answer would come out to be 2.83 centimeter. So eventually, option number A would be the correct option for question number 5. Now let's proceed to question number 6.